Hey, 8th graders, welcome to your phase change engineering internship. This is going to be day one. I've kind of condensed these just a little bit, just so you guys are aware. But today's day one, and our focus is going to be talking about PCMs, which obviously you guys don't know much about right now. But as we work through this assignment, you guys will learn a lot more about PCMs and how they're going to play into this engineering internship. Okay, with that being said, your learning targets for today, I can describe thermal energy transfers involved in our PCMs, and I can identify the 3 design criteria for this project. So this is going to be a project that starts off individually, but then as we start working into collecting our own data, we're going to join into a team, and with that team, you guys are going to be making proposals to the boss, me, as to whose design is going to be the best design and why. Okay, so that's kind of the long term of this engineering internship. All right, for your bell ringer today, you guys have this message to read, so go ahead, take a second, pause this video, read your guys' message on your bell ringer, and then we will move forward. Okay, since you guys are done with your message reading, you guys will open up this video link right here. It's called Welcome to Futura. It looks like this. It gives you guys just a little bit more background as to what we're going to be doing in this engineering internship. Okay, so go ahead again, take a second, pause this video, go ahead, watch the Welcome to Futura video, and then come on back when you're ready. All right, next thing for you guys to do is read. So you guys will open this link. When you guys open it up, it might not go directly to the article that you guys want, which is the phase change materials. So if you click on your table of contents up here, you guys want chapter 2 phase change materials. Okay, I want you guys to pause this video, take a second to read through this article. You guys are going to learn all about what PCMs are and how they're going to be incorporated into this week or so long project. They're really important that you guys understand, so make sure you do a good job reading. As you guys read, you guys are going to be looking for the answer to these questions. What does PCM stand for? What are PCMs? So explain what they are. Okay, obviously you're telling me what they stand for up here, so what are they? Okay, explain them in your own words. Again, all of these should be in your own words. None of them should be copy and pasted from the article. What are PCMs commonly used for? So where do we find them? Where do we use them for? Use the concepts of energy transfer and phase change to explain what happens when we boil the PCMs. So the PCMs that you guys are going to read about and use in the kind of the simulation for this are going to be a lot different than the PCMs that you guys see in this picture here that we're going to do a lab on here in a second. In order to get these PCMs heated up, we actually have to boil them and transfer energy into them. Okay, so think about that as you guys read. And again, you guys should have a pretty good description in your article about how they work. So use the concepts of energy transfer and phase change to explain what happens when we boil the PCMs. Okay, so obviously in there somewhere you probably got to talk about energy transfer and phase change. Okay, what happens to the molecules in the PCM as they lose energy? So when they lose energy to their environment, what do the molecules do? And then finally, how will the PCMs be used in this project? So you guys, again, should have a pretty good idea so far between the video, the message, what we've talked about so far in the PCM article about how we might be incorporating PCMs. Okay, so go ahead, take a second, pause, read your phase change materials article and answer those 6 questions. And when you're all done with slide 7, go ahead and come back to this video and we'll move on. All right, hands-on. One thing that we're going to talk about is supersaturated solutions. So the little hot packs that you guys are using in class in this demo are an example of a supersaturated solution. Basically, when we think freezing, because we're so used to ice being the main thing that we notice freeze or turn into a solid, we always think of that as a very cold action. But what you guys will see is in this lab today, we're going to have a phase change that releases heat. So when we touch something, we're going to feel that heat or that energy going into our hands, and it's going to feel hot in this phase change. So when it turns from a liquid to a solid, it's going to feel hot, okay? We're also going to notice in the video I showed you guys today another phase change that doesn't have any temperature change whatsoever. We'll just see that solution change from a liquid to a solid. So modeling freezing liquid to solid, your internship coordinator has provided you with hand warmers that you will use as models to learn more about how the PCMs and the portable incubator transfer thermal energy during phase changes. Follow the steps below and then answer the questions. So the first thing I want you guys to watch is this supersaturated solution. It looks like this. Okay, you guys will start out with this little round bottom flask. Inside of that is a mix of, God, what is it? I forgot already. I think it is sodium acetate. Okay, and basically, if you guys think, I always like to use this example. If you guys have your sugar and then you pour it over your guys' Rice Krispies or whatever in the morning, I mean, if you're like any normal person, you guys are going to put a lot of sugar on that. And some of it will dissolve and make your milk taste sweet. But for that stuff that doesn't dissolve, it's going to sit at the bottom of your guys' bowl. Okay, this is very similar, except if we were to boil your milk, we could force that sugar to dissolve. Okay, in this situation, we have sodium acetate, and we've added it to the water to the point that we've added so much that sodium acetate won't dissolve. Okay, so what we did is we heated it up and we forced it to dissolve, and we've made this super saturated solution, meaning there's more powder in it than that can actually dissolve, but we've made it dissolve. Okay, what happens is this makes for a very unstable situation, just like you guys saw at the beginning of our phase change unit with the water bottles and how we were able to turn those into a solid really quick. Just by adding a little chunk of the sodium acetate, you guys will see this liquid turn into a solid and crystallize really quick. Again, because this is just a different chemical and it just has different properties, this phase change that you guys see doesn't actually have much of a temperature change associated with it. Okay, we're not going to feel it get really, really cold or really, really hot. It's just going to feel normal. Okay, so go ahead, take a second, watch this video about supersaturated solutions, and then we're going to move on to talking about the demo that we did in class today. Okay, so you guys are going to be looking at a different type of supersaturated solution in these little hot packs that we're using. Again, these hot packs are different than what we're going to be demonstrating when we're talking about building the incubators for the babies. These heat up naturally when they phase change. The ones that we're going to use are actually going to get their heat from us transferring energy into them. Okay, so you guys will first start by getting some before data. You guys will need to go on to the next slide to get the data for this. So before, you're going to look at the starting phase. Is it a solid, liquid, or gas? And then you're going to write your observations about it before the phase change. Okay, and then also I'm going to show you guys in the video the temperature of the hot pack before the phase change in degrees Celsius, so you guys will record that before temperature as well. Okay, your video to observe this is down here. So record observations in the table about the hand warmer in the column titled observations before bending the disc. Circle the hand warmer starting phase and note how the hand warmer looks and feels. Prepare a timer. So you guys at home will have a little bit easier because you guys can time it as you guys watch the video. If you guys need to, you can restart the video. It's pretty easy. So make sure you guys have like a phone or a timer or something on hand as you watch the video so you guys can time how long it takes to phase change from the start of the phase change to the end of the phase change when it's all turned to a solid. Okay, you guys will see in the video that I will gently bend, and it takes me a couple times in this video, but I'll click this little metal disc in there a couple times, and then you guys will be able to tell when it starts to phase change. So gently bend the metal disc in the hand warmer. After activating the hand warmer, leave it undisturbed on the table. Time how long it takes for the hand warmer to finish changing phase, so that's what you guys are going to do from the video at home. Circle the hand warmer's ending phase and record observations in the column titled observations after bending the disc. Note any changes about how the hand warmer looks and feels. I also show you guys the after temperature, so you guys will record that all here. So ending phase, solid, liquid, or gas, any observations, time it takes for the hand warmer to finish changing phase, and then you guys will do your final temperature, and then go ahead and calculate your change in temperature. So subtract your before and your after. So take your before, subtract, and find out how much it heated up in this case. Okay. And then finally, in this activity, thermal energy was transferred. You guys are either going to circle in or out of the hand warmer while it changed from liquid to solid. So again, while it is phase changing, what's happening to the thermal energy? Is it being released into its environment, or are we putting thermal energy into it? Okay, my evidence of this is, so you guys even at home should have plenty of evidence to explain that. Okay. Modeling, so go ahead and I'll give you guys a second to pause this video, take care of that, and then we'll talk about how we go the opposite route. I don't have a video to show you guys that, but I'll talk about it. So go ahead, pause, complete through slide 12, and then come on back. All right, to finish up this hands-on activity, again, I don't have a video for this, but what we did in class then, and there was no data to really collect for this, is we took now your hardened solid hand warmers that have released all of their energy. Okay, we had energy transferring out. That's why it felt hot to our hands, because that energy was going from the ice pack into our hands. And then I threw it in boiling water, and just like you would an ice cube, okay, we want to add energy to get it to melt, so I'm transferring energy into it. that's causing it to melt and go back into its liquid phase. Okay, so your internship coordinator will demonstrate how to reheat the hand warmer by placing it in boiling water. The reheating process is the same for the PCMs used in the portable incubator. So that's important right here. Again, these are different in that they give off heat when we crack them and they turn into a solid, but the PCMs that we're going to talk about for the rest of this unit are really different. In order to heat those PCMs up, we have to boil them. Okay, in order to heat ours up in this experiment, we just have to click that disc. Okay, so they're a little bit reverse in how we add energy to them. So again, that's kind of what you guys need to be brought to light here of. So to answer the questions below, hand warmer phase before reheating, you're going to circle. So again, before we stuck them in the boiling water, were they solid, liquid, or gas? And then before, write a prediction as to what will happen to the hand warmer as it is being boiled. And then, again, you guys aren't seeing this, but you guys will see that it turns into a liquid after we boil it. So it's back to that original state before we crack the little metal disc. So the hand warmer phase after reheating it, solid, liquid, or gas. In this activity, thermal energy was transferred in or out. So you guys are going to circle that. Of the hand warmer as it was boiled, changing it from a solid to a liquid. My evidence of this is, so you guys can talk a little bit about that. Okay, and finally, you guys have this little activity to sum up your hands-on activity. Circle in or out for each statement below to complete the diagram summarizing thermal energy transfer during the melting and freezing changes. So if we're going from a solid, melting it into a liquid, you guys would circle or highlight either in or out. Thermal energy is transferred in or out. Okay, going from liquid to a solid in our freezing phase change, thermal energy is transferred in or out. And again, this all should be a lot of review from what we just finished up in our phase change unit. Okay, so go ahead and complete the rest of those hands-on activity questions, and then we're going to go ahead and move on. Take a second and pause if you need to. All right, to wrap up this assignment, some important vocab for you guys to know is constraint is a limit or a restriction. We're going to have several constraints that we look at during this project. And then obviously the main theme for today was a phase change material, or a PCM. Is a substance that stores during heating and releases during cooling large amounts of energy during phase changes. So the whole point is that we have something that's going to be able to release heat to these babies in the incubator. Okay, to finish up this assignment for today, you guys have another article to read, so open that up. Again, it might take you guys into where you left off. So go ahead, choose chapter 1 on this one. You guys are going to learn a little bit more about the specifics of what you guys will be designing in this team project. So this is request for proposals. So do a good job reading through that. And then you guys will answer this question. What are the 3 design criteria or purposes for this project? Again, just in your own words, summarize it. I don't want you guys copying and pasting it. So go ahead, tell me what 3 design criteria you need to meet for this project. And then don't forget to do your exit ticket. Any questions, yes or no? If yes, type them below. And then 4, 3, 2, 1, how do you guys think you did on this assignment? Go ahead and hand it in. I hope you guys are having a great day, and I'll talk to you soon. Bye.